Hi guys, my name is Kseniia. Thank you, Jana, for such a great introduction. And today we will talk about Bluetooth Low Energy and iBeacon development. And during this talk, we will cover such topics like implementing Bluetooth Low Energy interaction with devices using Android 5 and higher, and for devices prior to Android Lollipop. Also, I will show you what is beacons, what is these devices, what they can do, and how to implement background scanning for iBeacons, and how to turn on your Android smartphone into iBeacon emitter. And in the end, we'll show a demo project for Android Wear that shows how we can use the beacons. So as you can see on this picture, beacons, it's like teeny devices. And on the picture and on my left hand is a Polish beacon contact. On the right hand, it's a Chinese analog. And so let's talk what is these devices and how they works. So at first we should clarify what is beacons and what is iBeacon. So beacon is such device, and iBeacon it's a protocol standardized by Apple company 2 years ago. So iBeacons works with Bluetooth Low Energy signals, which Android devices can detect starting from API level 18. And iPhones can detect from 4S model. Let's look on the internal structure. So iBeacon consists from obviously Bluetooth Low Energy model and from like a called system on a chip. It's a small microprocessor and a battery. And this battery can be used in average from 1 and up to 3 years. It depends on beacon vendor, and it depends on frequency which signals will be emitted. And in general, how it works. Beacon emits some signals, and our devices can detect them. And using this beacon coordinates and signal strengths, we could define the location of the device and maybe perform some actions. So typical usage of the beacon technology is like is the next. We scan some beacons emit the signals. We scan the signals. Our application scans the signals and send it to the server. Then, as I said, using the coordinates and signal strength of the variety of beacons, we could detect the location of the device, and then on our server we could specify more details and send more specific reply to our application. So as example, we have beacons on the shopping malls, and then our customer are going through the mall, and on some stands or nearby some shops, we could send them some advertisement or some discount and invite the customer go inside the shop and enter his discount. And a bit talk what is Bluetooth Low Energy. Bluetooth Low Energy is a new standard. It was announced 6 years ago in 2009, and the main goals of the Bluetooth Low Energy is reducing power consumption for Bluetooth interaction. So it mainly will be used in wearable devices, in some embedded devices, in Internet of Things that become more and more popular. So for next years, I expected maybe increasing of popularity of such devices. And what is difference between classic Bluetooth protocol and Bluetooth Low Energy? So at first, these protocols are not backward compatible. So if your device can detect Bluetooth Low Energy devices, it's not the same that your device will be detect also Bluetooth devices. By the way, they have almost the same radio frequencies and the same speed. And let's consider more technical specification. So the range is almost the same. The same is speed and frequency. But in previous classic Bluetooth, we have significant limitations for asynchronously interaction with Bluetooth devices. It was limited by 7 simultaneous interactions. But in Bluetooth Low Energy, we don't have such limitations. And also significantly reduced minimal total time to send the data. So for Bluetooth Low Energy, it's almost in 30 times less. It's just 3 milliseconds. And as I said, the main goal of Bluetooth Low Energy is reduce power consumption. So such devices can work for years. So at least 1 year will be enough and will be maintainable for such purposes like indoor navigation, like using beacons in shopping malls, in the other stuff. And if you want, we could interact with Bluetooth Low Energy device like with a classic Bluetooth device. And so let's go deeper in technical details. Interaction with Bluetooth Low Energy devices are based on GATT. It is a generic attribute profile, and this is the standard protocol for interaction with Bluetooth devices. And we have some typical entities for GATT. It's a client. Client detects the signals, the Bluetooth Low Energy signals, and detect devices, and server emits the signal. So beacons are the servers, and our application will be the client. And the signal consists from characteristics. This is data transferred from one device, a Bluetooth device, to other. And service is a collection of related characteristics. So, for example, if we have a health thermometer, our service will include characteristics of temperature measurement and time interval between measurements. And descriptor, it's like a more human-readable definition of our attribute, and could include some more specific information about attribute. So what are basic GATT operations? It's discovering devices with all UIDs, discovering devices with specific UIDs, and discovering UIDs with some filters. And if we find some services as matched, we could get some specific characteristics, find some specific characteristics by a filter. And let's look how it works on Android. And at first look what is beacon advertisement. So beacons emit each time the signal with some frequency, and the data that is produced called scan response data. This data, it's not very big, it's like a small packages up to 31 bytes. And this response, this data, divided into some structure. It's not like random or 31 bytes in any format. They have a strong unified structure, and now let's look how it implemented. So advertisement data structure divided in 2 blocks. The first block is about some flags related to BLE, and in each data structure, the first byte always show remaining length of the other AD structure. So as you see at the AD1, we have only 3 bytes. The first indicate remaining bytes, that is 2, and the second byte indicates advertisement data type, and the third byte consists from 5 plugs that indicates some Bluetooth of energy specific characteristics. And ID structure too, it's more interesting. So first byte is the same, indicates remaining length. The next byte indicates manufacturer specific type. So FF indicates that it is manufacturer specific. And the next several bytes identifies vendor. So if you turn on your device into beacon emitter, it's equals to 224, that is Google manufacturer ID. And if you use the other beacons, it's equals the other values that corresponds to device beacon manufacturer. And the next 2 bytes are indicating beacon prefix. With the same standard, we could some predefined beacon prefixes. And the next part, it's the next 16 bytes is unique beacon identifier. So we, in general, distinguish beacons by their UIDs. And other parts, other 2 bytes, it's a major and minor characteristics. So if we have, for example, a shopping mall, we could indicate, we could distinguish beacons in using UIDs and using major and minor parts. So, for example, if we have beacons on several levels, and in each level there is a room, we could set the major value to indicating our floor and the minor value indicating our room. And the last characteristic is TX power. It equals the maybe etalon signal. It's called etalon signal because it indicates the strength of signal if our device is located in 1 meter from beacon. So this is an example of package data structure. And to summarize, our data divided by beacon prefix, this information about vendor and beacon specifications, then it's proximity UID that indicates the beacon, minor and major parts that consist from more specific values to distinguish our beacons, and TX power, so we could measure our strength of signal. And let's look how it works on Android. So Android supports BLE devices starting from Android for 3 versions. It's equal API level 18. And we have central and peripheral devices. So central devices scan the signals and peripheral devices emit the signals. And as I said, we have corresponding entities. It is a GDG server and GDG client. And from this version also included Android hardware Bluetooth LE feature. So before installing the application, we could check if our device supports BLE or not. So how it is implemented in Android for 3. At first, we could check. We should check for permissions. So first one, we need 2 permissions, Bluetooth and Bluetooth admin. So first one permission allows to interact with the devices, establish connection, and send the data. And the second permission allows to change system settings and allows to detect the devices. And as I said, if you don't want to allow users with that don't have BLE support, hardware BLE support, you could just add user's feature Android BLE required true, and the user will not be allowed to install the application if device don't have BLE. And if you specify the false for this option, you should check this, you should handle manually if device has BLE or not. And in order to interact with BLE, you should create Bluetooth adapter, and all BLE interactions are done using Bluetooth adapter. So it can be retrieved from Bluetooth manager, and Bluetooth manager could be retrieved using get system service method. And then you should enable your Bluetooth if it is not enabled previously. And you can see on the second piece of code how it should be done. And then always you need at perform start LE scan, but it has parameter. It has one parameter callback, LE scan callback, and you should override on LE scan method where you need to parse the data that we scanned from the detected from the beacon. And how beacons are interacted with Android 5 and later devices. So from Google I/O 2014, the interaction with Bluetooth Low Energy devices was totally improved. They introduced a new API to working with BLE devices, and new functions have to perform BLE background scanning, have to filter, have to pass filter to our scan methods, and there is two modes. First mode, it's a low power mode. So if you want to reduce power consumption, we should use this mode. And if we want to fast detect signals, we should use the second mode, low latency mode. So this is the comparison between these two modes. And as you can see, using low power mode, we could reduce battery consumption almost in 2 times. But we have some limitations in detecting the signals. So for low power mode, it's 0.4 milliseconds, and for low latency mode, it's just 100 milliseconds. And how Bluetooth detection, how beacon detection looks like for Android 5 and higher devices. At first, to order to perform scanning, you should at first set the scan filter, and it consists from manufacturer data. It's like expected data that we are going to receive from the beacons, and data mask. So we could specify the fields, the bytes that we should include and we should consider. So data masks indicates this is array of bytes of 0 or 1 that indicates what byte we should consider from manufacturer data. And also we should set the scan settings, and in the scan settings we need to specify the scan mode, and in this piece of code it's low power mode, because in most cases for us it's maybe more properly to save the power consumption. And then after the setting the filters and the settings, we should perform start scan method, and also like a previous interaction with Bluetooth with Android for 3 versions, we should create a callback instance and override on scan result method that also should parse the data, but in a bit different mode. And also, we could retrieve the RSSI. It's a strength of signal, intensity of signal, and using this value, we should identify what is distance between our beacon and device. And the last things about Android 5 and higher interaction with BLE, we could turn our device into beacon emitter, but it works not with all devices. It works only with Nexus 6, Nexus 9, and higher devices. And we could create Bluetooth LE advertising and advertise data, advertise settings, support classes. So let's look at the examples. And as you can see, we also create advertise data builder and put our values that indicates manufacturer ID, prefix, and all bytes from the structure to the our builder. Also, we append the UUID of our beacon. So in general, we could set up different UIDs for our smartphone, but in documentation, there is no limitations how much that should be, but maybe from my point of view, it's not properly to set up a lot of different UIDs for one smartphone. Also, you could put the other values like minors and majors and TX power. And then you also should set the settings. And the settings will also set Advertise Mode and TX power level. So we could indicate what is the distance from our device that is like a beacon to a device that will be scanned, our smartphone beacon. And as you can see, we could set TX power level. In this example, it's medium, so we could imitate some strength of signal. And to perform emitting the signal, you should just call Bluetooth LE advertiser start advertisement and pass the all defined parameters. So the technical part is over, and I will show the demo application that was created using the beacons and Bluetooth LE. The application was created for smartwatches, Moto 360, and this application allows to interact with beacons that are located in shopping mall. So if you're going across some shops, and in these shops there are some special propositions for you, the nice button will appear. It looks like a chat head button from Facebook, and it will appear, and then if you click on it, you will see, oh, you have some discount in this shop. If you don't want to participate, you could just swipe left, and this discount will disappear. And if you click on this discount, you will see the barcode, and can go inside the shop, scan this QR code, and receive your discount. And one note about this nice button: if you're don't interested in some discounts, you can go forward, and this nice button will disappear automatically when you will go outside the region of visibility of this beacon. So this is a live example from my watches, how it's look, and maybe this library will be, these examples will be open source sometime later, which allows you to create some similar applications or some use cases using beacons. And let's also consider where it can be used. So at first, as I said, in shopping malls. The second is in creating an application for runners. So if runners are going across the track, it not be allowed cheating, so the check-ins on the control points will be done automatically. And then it can be used for indoor navigation. For example, at big conferences like Google I/O, we have a huge amount of rooms, a lot of people, a lot of sessions, and it's maybe too complicated, especially at the first day, to find a right route. And we could create an app, install it on the phone, and see real-time navigation, indoor navigation at the conferences, for example. The next is applications for museums. If we go to some exhibits, we don't need to manually start some audio guides. It should be done automatically when your device and you are inside of region of visibility of some beacons. And the next is for clinics. It's like an idea. So if you are going nearby some cabinets of doctors, you could listen information, see the working hours, see the reviews for this doctor, and so on. The next is applications for hotels. It's more similar like applications for runners, so check-in and check-out could be performed automatically using the beacons and just an application on your phone. And the next category is application for disabled people. So it's like audio guides, but if we have some complicated places, we could send some audio or other notifications to people with disabilities. That's all. Thank you for attention, and if you have any questions, please ask.
Okay, so we have this application for shopping. Do we need to start the application itself, or it would appear like getting broadcast receiver or something?
No, we need to implement background scanning, and it would appear automatically. It's like it would appear nice button on the device. So we perform background scanning. Okay. And if we receive a callback that scanning is finished and we receive the specific UID that we are interested in, we perform we show this button.
So it's initialize the Bluetooth communication between two devices, the beacon and device, just receiving some kind of information?
Repeat again?
I mean, how the application starts, or we need to start the application?
No, we don't need. We perform scanning in background for continuously background scanning.
So it's some kind of service?
Yes.
Yeah. Okay. Can we have some nearby communication implementation for that? I mean, the Play library offers some instruments for that, like playing sounds, like Bluetooth and so on, and just start the application using a Play library.
There is one library called iBeacon that performs on this actions and have a more easy structure than interaction and using Bluetooth Low Energy that I described. And you can check this library. It is open sourced ILT beacon, and it has some predefined set of actions that you mentioned.
Okay, thank you for speech. I'm Sergey. I want to ask you the question about About libraries, he said, but I know about different external libraries. You said that you can use Android 5.0 like Nexus, like a meter, yeah?
Yeah.
But as I understand, if I have on the device Bluetooth LE hardware, and I have external library from the other sources, I can set any device like a meter, Android device.
Probably,
Why not?
Probably no. And what libraries? Could you say the names of the libraries?
Okay, we have a library like Android, iBeacons. It's the same name. For example, I don't remember like protocol similar from beacons provided by Google. Eddystone, yeah?
Yes.
They has library too, and you can, I don't know, set any device if they have Android LE support. For example, Bluetooth 4. That's my question. How much the prices of iBeacon device? You know?
Yes, it's in range between $15 up to $40, $50.
Okay, similar for this, Google has or not Google the similar devices, like more cheaper or something like that. No,
I don't know.
But they have a protocol. That's why I ask you.
Maybe yes. And for a meter, using the standard actions, standard libraries, and standard Android components, maybe you don't allow to do the device as a meter, but maybe using that sandal we could check, but I have some concerns that it could depend on hardware, but maybe I will check later.
Okay,
because it's
that's about Nexuses. What they have that no have any other devices? Why we can use Nexuses like a meter and other devices no?
Because they have some hardware add-ons, specific hardware add-ons.
What's the devices like?
I don't know exactly, because my application just performs scanning of the beacons, and I don't have maybe more experience with emitting the signals. I know that it exists and it can be done on these devices, but maybe in my next research I will go deeper and investigate your question.
Okay, and the question that asked the man before me, I don't understand. It works like you only install the application and they automatically start them, yeah? Or we start them in the manual, this application?
It's like a service, so we perform background scanning continuously.
And we get broadcast to this service?
No, because we just receive a callback and
But how he has a signal? I don't understand really.
How, what?
Get a signal. But callback, it must be like some signal. In Android, it's like broadcast, as I know.
Yes,
maybe
but not for beacons.
No?
It's just a regular call. So it's just this function that will receive callback when the device is started.
Okay, thank you.
Hello, Kseniia. I have next question. From your presentation, I understand that we can measure distance to the beacon.
Yeah.
But can we measure direction where it's placed or no?
It could be done by maybe such sensors like an accelerometer and gyroscope, so we could manually define the direction using the sensors from the phone. Mm-hmm. It's like an inertial services, and we could do it manually.
I catch
and
you.
If we need more more accuracy and finding the direction, finding the distance. We could use.
So we should move phone or another receiving device and make some calculations, yes or no?
If it's necessary, yes, but if you need to define the more accuracy in your location, you could use the range of signals from several beacons and using, for example, triangulation, define more specific value and that have less похибку.
Okay. Another question: is it possible to store some information inside beacon? And if it's possible, what volume of such information could be?
As you can see,
How bytes I can write to beacon or so?
so the first AD1 package you don't allow to change. Okay. So AD1 structure we couldn't change. As for structure 2, if you emit the signal, you could change some beacon prefixes. Manufacturer ID you can change. Mm-hmm. And also UIDs also don't allow to be changed. It's predefined by the vendors. Mm-hmm. And but you can change major and minor parts. It's for 2 bytes each one. Mm. And X power also don't allow to be changed because it's echelon value. It's intensity of the signal that is located in 1 meter from the device. Mm, okay. So you have 4 bytes and major and minor parts. It's allowed to be changed.
Okay. And how long beacons what times of live of such beacons? How they can work from one power source or so?
How much time?
Without changing batteries or so?
From 1 to maybe 2 to 3 years, but it depends on the vendor. So I don't know how much time would work Chinese beacons because them hadn't don't precise specification. And for contact, its average is 1 year, so at least 1 year. And but contact are a bit expensive than Chinese analogs.
So it's very closely related to manufacturer of beacon, yes? As I understand. Thank you.
Okay, thank you.
I have one question. Okay.
Oh.
Okay. My friend developer from startup using iBeacon said me that from Android 4.3 it has some limitation in the using time. So when he deploy his app and try to debug it, so this time BLE just turn it off. So is it true? Is BLE usage have some limitation in time, and how we currently reduce it?
And what is limitations in time for your example? Do you know?
He was just scanning and getting the data.
In the documentation, there is no such limitations, and as for my examples, I also don't see such things. So maybe you're using some Samsung devices.
Okay.